Good morning everyone. Today we are going to learn one of the most important concepts in data structure, that is dynamic memory allocations. Commonly it is called as DMA. Until now, whatever we declared an array, it is something like int a of 100. So this compiler allocated the memory before the program started. But what if I don't know how many elements the user is going to enter? Should I create an array of size 1000? Should I create an array of the size 1000? What if the user enters only 10 numbers in that array? The most of the memory remains unused. So this problem is solved by using this dynamic memory allocations. So today's sessions will help you to understand how memory is allocated during the runtime and why every dynamic data structure like linked list, tag, queue, tree, graph depends on this dynamic memory allocations. Let us first understand why static arrays are not always suitable. Suppose if you are designing a student database, so how many students you want to will register for this next semester? Either this is 200 or this is 500 or this is 1000. So we don't know the beforehand. So if we declare the array size, that is int student as that 1000, only 120 students registers means the rest of the students 880 spaces is completely wasted. If we declare this array of student instead of this 1000, we are declare that as 100 and 150 students got registered for this one. So here the problem fails because an array size cannot increase. So it is a fixed size when we are declaring an array. So this is a major drawback of static memory allocations. Can we change the size of an array after compilations? No, obviously we can't able to change the size of an array after compilations. So instead of allocating the memory before the executions, we want wait until the program starts. So the user enters the required size, only then do we allocate the memory. So for example, how many students are there? So the user enters on 250. So now the operating system allocates memory only for this 250 students. This improves the memory utilization significantly, and this concepts which could be represented as runtime memory allocations. So in a real life examples, imagine that if you are booking the seats in a movie theater, the static allocation is like reserving 100 seats whenever the people come or not. So the dynamic allocation is like issuing the tickets only to the people who actually arrive. So that is, hope this example which gives you the better discrimination between the static memory allocations and dynamic memory allocations. So this memory allocation functions, in C we have 4 important functions are there. One is called as malloc, and other one is called as calloc, and third one is a realloc, and fourth one is a free. So although all 4 are important, today we will mainly focus on this malloc and free because these are used most frequently in data structures. So this malloc generally it is used to allocate the memory, and this free means it is releasing the memory. So releasing in the sense it has to free the corresponding memory space for the given variable. Malloc means it is memory allocations. So it allocates a block of memory from the heap. So general syntax, it is type of star p, it is a pointer, and we are representing this pair p is equals to type star malloc and byte size. So here if you are representing that, it is malloc generally returns the void pointer. So therefore we typecast it into the required point type. So this is called as a typecasting. So why we multiplying the size of int? So if you are seeing over here, we are supposed to multiplying this n with the size of it. So what does the necessity means? So if the program works correctly irrespective of the compiler or the machines. So if the compiler, for example, in some compiler, the int space, that is, it occupies 4 bytes, and in some cases it is represented by means of 2 bytes. So it depends on this machine to machine. So in order to, irrespective of this machines we use, we just using the size of in the malloc statement. So this statement allocates the memory for 100 integers. Suppose if the int size, it is int of the byte, that is 4 bytes. So the allocations that should happen for this 100 numbers, it is 100 into 4, it is 400. So 400 blocks is to be represented, and this p is a pointer, where this pointer pointing the first address of the memory locations. Can we have another example that explains about this malloc statement? So here we just have declaring this character data type. So this character data type, it has to representing over here, it is 10 into 2, it is 20 bytes are allocated. So here what we are supposed to do is, for the structure you are creating this pointer, and this pointer which has to storing this 20 bytes are allocated for storing that, so that this allocate memory of 10 complete student records. So if you are connecting it with the future topic, this is exactly how the linked list nodes are created. Suppose we have in the question that what if the malloc fails? So that answer in this slide over here. So the memory allocation is not guaranteed. If enough contiguous memory is unavailable, so this malloc obviously returns it as a null. So that's why we have to check this ptr is equals to null. So if that is checked whether this could be null, means obviously it just print over here as a memory cannot be allocated, or the memory allocation is failed. So every good programmer checks whether the memory allocation was successful. So what it happens if we access this null? The answer over here, it will give this program crash or segmentations fault. So then next we look into that Kellogg method. So this Kellogg is a contiguous allocations method used to dynamically allocate the specified number of blocks of memory of the specified type. Where what's the difference between this malloc and Kellogg is, the Kellogg initializing everything, initially it is initialized by 0. So in the malloc, it stores the, when you are creating that particular, declaring that one, it automatically storing some garbage value. Where in this Kellogg, it has to initialize as 0. So it won't have this garbage values is initialized as 0. So here in this malloc, what it happens means, it only allocates only one block, where this Kellogg, it allocates the multiple blocks. So that's the main difference between this malloc and Kellogg. And next one is free method. So free, which is when we allocate the memory, the operating system never removes it automatically. If we don't release, the memory becomes unavailable for future programs. So this is called a memory leak. So if you are doing this free PTR, it is a best practice for using this free PTR. Next one is called as a real log. So this real log, suppose initially we allocated the memory for 5 students. Initially we allocated it is for 5 students, and later some 50 students is joined. So in this cases, instead of creating another array, we realize the existing memory. So for that purpose, we just go with this real log. So it keeps the old data and expands the memory if possible. So that is the main use of this real log example. So here in this cases, what it happens, initially n is equals to 5, and later on what it happens, you are increasing the value, n is changing the value as n is equals to 10. So here you are using this real log. So what it happens to the first 5 elements, then they remain unchanged. What about newly allocated memory? So it has using this garbage values. So today we learned why static arrays are inefficient and runtime memory allocations, heap memory, malloc and calloc and reallog and free, and some linked list concepts which uses these dynamic memory allocation stacks, queues, trees and graphs. So without dynamic memory allocations, none of these data structure can grow dynamically. So I hope you have understand the concepts of this dynamic memory allocations. Thank you.